लिमसप और लिमइनफ की आज हम लोग बात करेंगे। तो उसमें सबसे पहले लिमसप का मतलब होता है लिमिट सुपीरियर। लिमिट सुपीरियर और लिमिट इंफीरियर का कंसेप्ट समझने के लिए हमें थोड़ा सा फ्लैशबैक में जाना पड़ेगा। We have discussed the concept of supremum and infimum. Supremum, what is supremum? What we do if I had a set, I find all the upper bounds, and out of all of these upper bounds, I always try to find the least upper bound, the upper bound which was least, and then I gave it a name as supremum. A similar thing will happen here. So let's say I have a sequence an and its sum will be a1, a2, a3. So I'll take the supremum of all the terms and I'll give it a name b1. Then I remove the first term and I'll take all the terms of the sequence from the second term onwards. I gave it name b2. Similarly, I will remove the first and second term and I'll take the supremum of remaining terms. I'll give it name as b3 and I'll keep going on. Now I'll again have a sequence of b1, b2, b3 and so on. This is another sequence. Now out of these sequence, all of these are superiors, hai na? All of these are supremums. Now take the least supremum, the infimum of all the supremums. This will be called the limit superior. Means all of these are superior, but I will take limit of that. The lowest limit of the superiors is called LimSup or limit superior. This is represented by this limit and then a bar above the limit term. This can also be represented as limit n tends to infinite supremum of an. Both of these are the symbolization. Now if I have a sequence which is not bounded above, if the sequence is bounded above, then we will talk about its LimSup. But if a sequence which is not bounded above, we will say its LimSup is plus infinity. This tends to plus infinity. Now the similar concept is for limit inferior. And what we used to do in infimum of set in the video of points of topology, you can just revise that. I search all the lower bounds of a set, and out of all the lower bounds, I say which lower bound is greatest, and this greatest lower bound I just gave a name of infimum. Same thing will happen here. You will take the complete sequence, you will take the infimum of that, you will name it as b1. Then I'll remove the first element and take the remaining sequence. I take the infimum and I name it as b2. Similarly, I'll do for the n terms. Now it will again become a sequence of b1, b2 and so on till bn and so on further. Now out of these all inferiors, I'll take the supremum, means the highest inferior, and that will be called as limit inferior. It is represented by limit and a bar below the term limit, or it can be represented as limit n tends to infinity infimum of an. Okay. Again, if the sequence is not bounded below, then it's LimSup or LimInf. It is not LimSup, it is LimInf, and it is also limit inf. The limit inf of the sequence will be said as negative infinite. Okay. Now some properties of LimSup and LimInf, limit superior and limit inferior. Now with the help of LimSup and LimInf, we can also know the convergence of a sequence. If you have a sequence, it will converge to the limit L if and only if its LimSup and LimInf are equal and they are also equal to the same limit. Now if the LimSup and LimInf are equal to positive infinity or negative infinity, then I will say that the sequence is divergent sequence. If the LimSup and LimInf are not equal, they are not equal to each other, I will say that the sequence is oscillatory. Now in oscillatory sequence, I have two options, finitely oscillatory and infinitely oscillatory. What does that mean? The common property is same, that the LimSup and LimInf are not equal. You can see it in both of them. But the condition is when LimSup and LimInf exist finitely, they exist and they are finite, then I will say finitely oscillatory sequence. And when both of them exist infinitely but they are different, then I will say it is infinitely oscillatory sequence. Some other properties. If alpha and beta are LimSup and LimInf of the sequence, then alpha and beta may not be the members of sequence. We also discussed that the supremum or infimum of a set is not necessarily a element of the set. Same thing is happening here. LimSup and LimInf are not necessarily member of sequence. They may be member and they may not be the member of the sequence. Next, if the sequence is bounded, now this is the blanket assumption for the next two things. It is a bounded sequence first of all. Now the supremum of the set of the limit points of the sequence is lim superior. Means what it is saying, you have a sequence, you find the limit points, all its limit points, make them a collection, so it will become the set of limit points, and you find its supremum, the supremum of the set, and this supremum of set will become LimSup of the sequence, है ना? And same thing will happen if you find its infimum. Infimum of what? Infimum of the set of limit points. This will become the LimInf of the sequence. Okay, now again some more properties. If the sequence is a bounded sequence and the LimSup of the sequence is equals to this capital M, I am representing it by capital M, then there will be a subsequence of AN that converges to M. Means the subsequence of the sequence AN is converging to the LimSup of the sequence. And the limit superior of no subsequence can exceed M. Means if this is the LimSup, you take any subsequence of AN, it can never converge to a number which is greater than the LimSup. So LimSup is the highest number or to which we can converge any subsequence. And same thing similar thing you can find for the inferior. If this is LimInf of the set, let's say small m, then you take any subsequence of the sequence, it can never exceed the, it can never be less than the LimInf. LimInf means it is the inferior, limit of inferior. So nothing can be less than small m, and no subsequence can converge. Now, if I have two sequences AN and BN, both of them are bounded. Now, these conditions are only if the sequences are bounded. So, what are the conditions? If all the corresponding elements of AN are less than equal to the corresponding elements of BN, then what will happen? Their LimSup of AN will be less than equal to LimSup of BN. And same thing will happen for LimInf of AN will be less than equal to the LimInf of BN. Same thing is happening. Now, for a convergent sequence, here the convergent sequence should be necessary. If we do the sum of two sequences and then you find LimSup, so what will happen? The LimSup of their separate LimSup will be added, and you can find the LimSup separately and then you can add them. For what will be happen for LimInf? Here the inequality will change. The LimInf of AN plus BN, the sum, and then you are finding the LimInf, then it will be greater than equal to the sum of LimInf of AN and BN. Now what about product? So if you want to, again it is a convergent sequence of positive real numbers it is saying, and you have two sequence A and B and you find the supremum LimSup of the product. It is LimSup of product. So it will be less than equal to the product of LimSup. Now what is happening for the LimInf case? The LimInf of the product is greater than equal to the product of LimInf of the both of the sequences. Okay. Now in addition, let's talk about the Cauchy sequence. And what is that? If you have a sequence, I will call it that this sequence is Cauchy when, what is the condition? If I take any epsilon, epsilon means whenever you see this epsilon delta greater than 0, you just think of a very small number, as small as possible. There exists a positive number m for every epsilon. For every epsilon greater than 0, there exists a small number m such that the difference of two terms of the sequence an and am is less than this very small quantity epsilon. For what? Whenever n is greater than equal to m. So this is the given thing, this is I am taking, and then there exists this. So what you can say, I can take any smaller number, as small as possible, after some point, means there will be some point m, and after all those points the term will be go closer, they will approach to 0, the difference will approach to 0. Now some properties of Cauchy function. If you have two functions a and bn, both of them are Cauchy. So what are the properties? There, if you do the sum, so their sum will also be Cauchy, their difference will also be Cauchy, their product will also be a Cauchy function. And if you do 1 by an is a Cauchy function, then 1 by an will also be a Cauchy function, but some conditions are given. None of the value of sequence, none of the member of sequence n should be equal to 0, condition number 1. What is the condition number 2? The limit of the denominator sequence, that should also not equals to 0. Only then there is a condition for this last one. Okay, some important theorems which Cauchy gave us so that we can check the convergence of any sequence. Now if I have a sequence with limit L, then what we can say, you just add the elements of the sequence till n and divide it by the value n. Now if you take the limit, you will reach the same thing. You will reach L here, you will also reach L here. This is called the Cauchy's first theorem on the limits. Now if there is first theorem, there is also second theorem. So what he says in the second theorems on limit, if an is a convergence to L, then but the condition is L should not be equal to 0. In this one L can be equal to 0, but in second theorem L is not equal to 0. Then what will happen? You just do the product of the members of the sequence, you take power 1 by n, then put the limit n tends to infinity. This will also be equal to the same limit of the sequence, n tends to infinity, an equals to L. But what is the condition here? L is not equal to 0. So these are the two Cauchy's theorem which helps us in solving many problems. Okay. Now you can get this PDF from the Google Classroom. Please do see the real analysis playlist, and join us on Telegram, like, comment and subscribe. You can, if you want to discuss deeper on this sequence thing, you can just use the Apostle mathematical analysis and mathematical analysis by the Rudin. So see you in the next video. Thank you. Bye bye. Tata.